Hello everybody and welcome to Devlog 1 for SFramework for Craft Studio. If you're not familiar with Craft Studio or SFramework, I recommend you go back to Devlog 0 and check out my video there, and you'll get a bit of an explanation as to what Craft Studio and SFramework are. So with all that said, let's get into it here. So the objective for this iteration of SFramework was to add friction to the physics engine of SFramework. So when I'm doing this, there's a few things that I have to consider. We have existing collision data, which will be useful, and we also have a collision resolution function that I'll have to modify. So we also want to look at the actual physics behind friction. If we look at the equation for friction, we see that the force of friction is equal to mu times the normal force. Mu is the coefficient that we are worried about, so that's what the developer would manipulate. And n is the normal force that we get from our collision data. So that's useful. We basically have everything we need. So now we also have to consider what an impulse is. So the equation for that is F, so the force times delta time, is equal to the mass times delta velocity. So in this case, delta time is just one game tick, so we can eliminate it from the equation, leaving us with force equals mass delta velocity. So in order to find our resulting velocity, like we do already in our resolution function, we need to do a little bit of manipulation. So we think about it, we can split our equation. So we have F equals m delta v, where delta v is our initial velocity minus our final velocity. And we can manipulate that and move stuff around. So first we'll divide both sides by the mass, so we're left with force divided by mass is equals to the initial minus final velocities. And then we're able to isolate that final velocity and end up with our initial velocity minus F over m equals our final velocity. So F right there is going to be our friction force, so we can sub that in. So our final equation is going to look like initial velocity minus mu n over m equals our final velocity. You'll see me implement that into our function. So the other thing we have to consider is that friction always acts in the opposite direction as the direction that our actor is moving in. So what we'll have to do is take our friction vector and multiply each component, so the x and y, by the direction of their velocities. So that way we'll get friction acting in the correct direction. You'll see me implement that, then we just have to move on to getting and setting that friction coefficient using both the public variable as well as an actual getter and setter, and then we'll update the doc to reflect those changes, and we're good to go. So if you want to check out SFramework, you can find it on GitHub. I'll put the link in the description, and you can check out all of the doc and even download it and use it from there. And then if you enjoyed this video, feel free to give it a like, or not. If you didn't like it, you can dislike it, I don't mind. And if you want to see more content from me, if you want to follow along with SFramework or any other development projects I go and do, you can subscribe to the channel, and I would appreciate that very much. And with that, we are concluding the SFramework Devlog 1. Thank you guys.